Now we are going to start with the functional group aldehyde and ketones. The both aldehyde and ketones actually contain this group, that is the carbonyl group. What is this? It is a carbonyl group. So if somebody asks you about carbonyl group, you should be clear with the answer that C bonded double bond with O and attached to this thing, any H or any aliphatic chain or an aromatic compound, but still if it contains this kind of group, it is said to be a compound with carbonyl group. So we have seen that, like if we talk about aldehyde and ketone, both contain this carbonyl group. So what is there in aldehyde? In aldehyde, this carbonyl group is bonded one with H and one with this R. This R can be, as you know, can be an alkyl group and it can be a aryl group, depending upon that whether we are talking of aliphatic aldehyde or we are talking about the aromatic one, right. So and in this case, if this two bonds are with alkyl or an aryl group, it is said to be ketone. So that means if you have a structure like this RCHO, it is particularly aldehyde, and if you have a structure like this, it is particularly a ketone. So both of them contain this carbonyl group. Now if we talk about this carbonyl group, like if we talk about it, so we will see that here it is having a double bond with O. So it is sp2 hybridized. So how many bonds? Two bonds, one is sigma and one is pi. You know that whenever two bonds are there, first bond is always sigma bond and other than that is a pi bond. So it has one sigma and one pi. Now there is lot of electronegativity difference between C and O. O is much electronegative, so it will attract shared pair more towards itself. So as a result, it will acquire a partial negative charge and it will acquire a partial positive charge. So we can say that the bond between this CO or a carbonyl group is actually polar in nature due to difference in the electronegativities. Now if we look for ketones, we will see that ketones are basically of two types, simple and mixed type. What is simple type? If you have two alkyl groups which are attached to the carbonyl group are same, if this R and R are same which is attached to a carbonyl group, it is a simple type. For example, it is CH3, CO, CH3, then it is a simple ketone because both R are same. Mixed one is that in which you have one R and the other R is somehow different. For example, CH3CO, C2H5. Here you can say this R is different and this R is different. So when these two R's are different actually, so it is said to be a mixed ketone. Likewise, we can also divide it and further in other categories. We can divide it in a saturated ketone and unsaturated ketone. Depending upon that, like if we have a structure like this, so there is all single bond, so it is said to be a saturated ketone. And if there is a double bond, at least minimum one double or triple bond, for example, if I have like this, let's take an example like this. Suppose I have a structure like this, here you can see there is a double bond. So that means the double bond indicates that it is an unsaturated ketone. Likewise, we can do for an aldehyde. For example, if you have a aldehyde like this, they'll have a single bond between, I'm talking about the bond between C and C, keep in mind. So it is again unsaturated aldehyde. But if it is present like this, because it contains a double bond, so that means it is an unsaturated aldehyde. So we can actually divide the aldehyde into saturated and unsaturated depending upon that whether the chain contains minimum one or two double or triple bond, and likewise an unsaturated if it contains, similarly like if it contains, it is an unsaturated, if it do not have that, and then it is saturated. So likewise you can divide. Now if we talk about the nomenclature, how we write the names, like how we write the common names and the IUPAC names for that. For example, I have an aldehyde. So when I am going to write a nomenclature for aldehyde, what I have to consider that in that, like you have a alkane, you have to drop the E of the alkane and it is being replaced by al. So that means E of alkane is dropped and it is replaced by the secondary suffix, that is the al. For example, I have HCHO. The common name for it is formaldehyde. The common name for it is formaldehyde, and for it is acetaldehyde. Now their common names are actually derived, like we know that if we will carry out oxidation of aldehyde, they are going to produce carboxylic acid. what type of carboxylic acid they produce, they are named according to that. For example, formaldehyde produce formic acid on oxidation, so that is why it is called formaldehyde. Acetaldehyde produce acetic acid on oxidation, that is why it is called as acetaldehyde. So depending upon that on oxidation what kind of carboxylic acid they are going to form, we just name them, we give the common names accordingly. And if we talk about IUPAC, then it is because it has one carbon, so it is meth. AN we need to put because it is a saturated one, and E is replaced by Al, so it is methanol. For example, in this 2 carbons, so eth, AN we need to write, and E is replaced by Al, so it is ethanol. And in case of ketones, if you want to write, again you have to keep in mind the first member of ketone is not of one carbon, because we have seen that it is RCOR, so minimum to minimum R will be of one carbon atom. So that means one carbon atom and one compulsory carbon atom of the functional group. So that means the first member will minimum contain 3 carbons. The first member will minimum contain 3 carbons. So here, like if when you name it, so what you do in the same way in the alkane, E is replaced by Un. E is replaced by Al. For example, I have CH3, CO, CH3. If I write a common name and if I write a IUPAC, so if I write a common name, it is because 2 methyl groups are same, so it is going to be dimethyl ketone. Dimethyl, and this is ketone. And if I am going to write common name for this, so what you have to do, like this is a bigger group, right? As you can see, it is carrying a 2 carbon atoms. So you will write it as alkyl, that is ethyl, followed by the other one, the small one, in an alphabetical order, ethyl, methyl, ketone. This is ethyl, methyl, ketone, means you follow a alphabetical order in that case. And if you like write about the IUPAC, so it contains 3 carbon atoms, so 3 means prop, AN we need to put, E is replaced by Un, so it becomes propanone. And here 1, 2, 3, 4, so 4 carbon atoms, that means bute, AN we need to write, E is replaced by Un, so it is butanol. So likewise you will be writing IUPAC in common name for rest of the members. And if we talk about the isomerism, that what kind of isomerism it can show, actually they can show a chain isomerism. What is that? The chain one is that, for example, you have this kind of thing. Let's say in chain isomerism what happens is that for example this means the chain gets shorter, this group may migrate to this place or to this place, so it may migrate to any of the place. So for example we have this thing. So this groups migrate, I say, let's say to this point. So this is again a chain isomerism because it will be 1, 2, 3, 4, 5, 6 hexanon, and it will be 2 methyl, 1, 2, 3, 4, 5 pentanon, right. So means just the shortening of the chain, condensing them. And similarly can be for aldehyde. For example, you have a aldehyde here, right. And in the second, if we write in chain isomer for it, let's say we'll get this. So what is it? It is 1, 2, 3, 4, 5. It is pentanol. Pent for 5 carbons, AN and Al for aldehyde. And here it is 2, 1 will be numbering for, we know that we have to number from the functional group should get the least number. So it will be 3 methyl, this thing 1, 2, 3, 4 parent carbon atom has 4 chain. So butanol. 3-methyl butanol. So this will be a chain isomerism. Now if we talk about position isomerism, so this can happen, for example, I have this thing. So if I number from this side, let's say it is 2-butanol, and in the other way when I am writing it, so let's say that it is, let's say it is 3-butanol. So anything can happen, just the change of place of the functional group. Similar thing can happen with aldehyde. Suppose you are having an aldehyde here at first place, you may have another place also. So that is just the numbering of the functional group. Third is the functional group, in which it will get changed. A functional group will itself get changed. For example, like if we talk about this thing, this gets converted into a ether, right. So likewise we have metamerism. Metamerism is a kind, it is particularly shown only by ketone. What happens actually, suppose if I write a ketone here, this actually occur for only those functional groups which are like on either side R are present, means this kind of this thing isomerism is shown only by the functional group which are enclosed within the R. That means R is on the one side and R is also on the other side. For example, if we talk about this, it is 1, 2, 3, 4, 5. So that means it is at third place, and equal number of 2 C's here, 2 C's here. Now if I write in this case, suppose I have this way 2, 3, 4, 5. So here 1 R is at 1 C is this place and 3 C is other place. So that means when I will write this, it will be C2H5 CO C2H5, and here if I am going to write, it will be CH3 CO C3H7. So that means just this, you can see that the number of carbon atom is same 2, 3, 4, 5, and here also 3, 4, 5, but just the you can say the number of carbon atom across the functional group is different. So this is what is the basic introduction about the aldehyde and ketones. Now we are going to start with the preparation. I think you got it, that what is exactly in carbonyl group, what is exactly an aldehyde or ketone, what is mixed and simple ketone, what kind of isomerism, how you are going to write the nomenclature. If you talk about the common names, how we write the common names, I think it's clear. So we'll start with the preparation now. So just look at the board carefully.